Okay, as we did the maths for this, I hope I've got it right. It's difficult thinking and talking and programming at the same time, so you'll have to forgive any errors. I'm going to set up my two fractions. I'm going to have fraction 1 and fraction 2. So my fraction 1 was a half. So if I change that for a half. And my fraction 2 was 3/4. So if I copy that, and paste that in there. Fraction 2 was 3/4. I can then sort of add them together. So let's create another fraction to hold the result. Fraction, and if I call it f, I don't need to change that. Fraction f equals new fraction 111. Okay, so all I need to do now is add them together. So I need to call a library routine. So f equals f library dot add, and give it my two fractions f1 and f2. f1 and f2. Now hopefully that's going to add them together. It's going to reduce it to the lowest form, and I'm going to be given 5/4. So if I just put that in there to check, 5/4 is my result. So fingers crossed. Perfect. Okay, and we're going to prove now that it doesn't matter which order you give these in. So if I swap that round, have it as f2 and have that as f1, run the program, I should have the same result. Rules of maths, there we go, 5/4. So that's quite neat. At the moment I have got a way of expressing fractions. I've got fractions in their lowest form, and I'm performing maths on the fractions by adding them together, and the results are coming in lowest form. So we're well on our way to having a fraction data type. There's still a lot of work to do though. I'm going to try now to work on the rest of the functions, and when I've done that we'll take a look at some of the rules, see what's going right, what's going wrong.